Today in this video lecture, we will see numerical 2 on strain energy and impact factor. First of all, very sorry for noise disturbance. This is numerical. A steel rod 40 diameter and 5 meter in length is suddenly subjected to an axial pull of 50 kilonewton. Determine the work done, maximum and instantaneous elongation. And assume modulus of elasticity is 2 into 10 raised to 5 MPa. So in this numerical, they have given us this diameter 40 length of that bar 5 meter, and axial pull suddenly subjected. This word is important. Suddenly subjected work is important. Why this suddenly subjected work is important? Because this suddenly word comes, then the stress is not only P by A. This 2 comes to the stress formula, 2P by A. So remember this. And this axial pull P is 50 kilonewton. Determine the work done, and you all know work done is nothing but the strain energy. And second is maximum and instantaneous elongation. So first write given data. Diameter denoted as capital D is equal to 40 length is 5 meter, and axial pull denoted as P is 40 kilonewton, and this E modulus of elasticity 2 into 10 raised to 5 MPa. And to find is work done, that means strain energy, and strain energy denoted as U. We all see in our previous lectures this work done is nothing but the strain energy. So that's why the strain energy notation I write here U. And second, maximum and instantaneous elongation, and elongation is denoted as delta L. So see this DL, PE, and we have to find this U and DL. So this U formula, we all know this U formula is, see this U formula is sigma square upon 2E into volume. Volume, that means area into length. We have this area of that circular steel bar is pi by 4 into D square, and we have D. So this term is complete. This L we have length of that bar is this 5 meter. This E is given data 2 into 10 raised to 5 MPa. We don't know this stress, and this stress is nothing but the this suddenly what comes suddenly for suddenly applied load. The stress is 2P by A. When we put this stress in this equation, then we get this U, strain energy or work done. And second is delta L, and delta L formula is straightforward. Delta L is equal to stress multiplied by length upon modulus of elasticity. We have stress, we have length, we have modulus of elasticity. Simply we find this delta L. So solving methodology is, see, first we write this stress, then second this, and then third this. So first find instantaneous stress or suddenly applied stress. due to right like due to suddenly applied load stress stress due to suddenly applied load, right like this wording like stress is denoted as sigma. Stress due to suddenly applied load is 2p by a. 2 as it is, p is this 40 kilonewton. That means 40 into 10 raised to 3 newton. Put this value, p value is in newton because we need this stress value is in newton per mm square. And area is area of that circular steel bar. That circular steel bar material is steel and diameter is 40 mm. And you all know circular bar area pi by 4 into d square. अच्छा लगा 60 pi by 4 into d square 40 square. So this 2 into this this calculation is 1256.63 and then this stress comes $63.66. See, this P is 50 kilonewton here. That means here also 50 kilonewton. $79.58 MPa. And second step is to find work done. And work done is equal to strain energy, and strain energy formula is sigma square upon 2e into volume, and volume of that circular bar is area into length. So sigma is this 79.58 square divided by 2 into modulus of elasticity is 2 into 10 raised to 5 MPa. Area is this bar diameter area 1256.63. And length of that bar is 5 meter, that means 5000 mm. I told you this in one of our last lecture that put values in Newton mm or in kilonewton meter. Then we get unit like this, Newton per mm square or Newton mm or kilonewton per mm square or kilonewton meter. So after solving this, 79.58 square multiplied by 1256.63 multiplied by 5000 divided by 2 into 2 into 10 raised to 5 is 99.48 into 10 raised to 3, and unit of this work done is Newton mm. Work done is nothing but the strain energy, and strain energy is denoted as U, and value is 99.48 Newton mm. 99.48 into 10 raised to 3 into 10 raised to 3 Newton mm. That means 99.48 joule, and this joule is nothing but the unit of this joule is nothing but the unit of work, energy and heat. And this 1 joule is equal to 1 into 10 raised to minus 3 kilojoule, and 1 Newton mm is equal to 1 into 10 raised to minus 3 joule, and 1 Newton meter is equal to 1 joule. So remember this joule is nothing but the unit of work, energy and heat. 1 joule is nothing but the 1 into 10 raised to minus 3 kilojoule. 1 Newton mm is equal to 1 into 10 raised to minus 3 joule, and 1 Newton meter is equal to 1 joule. So this is just for information purpose, and our second solving methodology is delta L, elongation. See, due to this applied load P, this body, due to this applied load P, this body deform like something here, and this change in length is nothing but the elongation, and formula for this elongation is sigma L upon E. Sigma is nothing but the stress. Stress is 79.58 MPa. Length is 5000, and E is 2 into 10 raised to 5. So 79.58 into 5000 divided by 2 into 10 raised to 5 is 1.9895. That means 1.98 mm, and is approximately equal to 2 mm. So that means due to this 50 kilonewton suddenly applied load, this steel rod elongate 2 mm, and work done on this steel rod is 99.48 joule. and this work done we find by using strain energy equation, and elongation we find by using this sigma L upon E equation, and given data are this diameter, length, P and E. So this is numerical. Thank you very much for watching this lecture.